Hello dear students, welcome to Physics Maestro YouTube channel. In this video we will be learning about the continuation part of the calorimetry chapter, and this is lecture number 3. In the previous classes we studied the basics about the chapter calorimetry. Okay, so those are the heat and its units, temperature and its units. Then we learnt about in lecture number 2 we learnt about specific heat capacity, thermal capacity, and the relationship between the units of heat and temperature, relationship between the units of specific heat capacity and thermal capacity, and then we came to know about the relationship between the thermal capacity and specific heat capacity in the previous session videos. In today's class we will be studying about, or we will be discussing about, three concepts, important concepts. Okay, so one of those is specific heat capacity of some common substances, and then principle of method of mixtures, and the device calorimeter. It is also called as principle of calorimetry, and then we will be studying about natural phenomena and consequences of specific heat capacity. So as you know that, so in all these things one thing is common, that is called as specific heat capacity. Okay, so what do you mean by specific heat capacity, how the formula came, and so what is the definition of specific heat capacity? These things we studied in the previous video, and so those who are new to this video, I request you to please go and watch that video, watch the previous session, and so you can understand this session very clearly. Clear? Yes, fine. So as I told you, specific heat capacity is the major concept that we will study here. Okay, so here natural phenomena and consequences. So from this is very important, and from this concept we will get a 1 marks question or 2 marks question, give reason or application type question we will get. Okay, fine. So hence it is very important to understand the concept. So principle of method of mixtures, as we know that, okay, so the problematic question in order to solve, so these are not the subjects or the concepts in which if we know the formula we can directly apply the values and get the answers. Okay, so we must know how to apply the values, how to tabulate the values. So these things also we must know. In order to know that one, we must be very much strong in the basics. Okay, fine. So here you will get how this the formula, that is principle of method of mixtures, there you will get one formula, how that formula will come, all these things we will discuss here. And so specific heat capacity of some common substance, in order to know this one and this one, so we need to understand these concepts with respect to some common substance which we need in day-to-day life, which we use in day-to-day life. Okay, fine. So this is just the introduction about today's class. Okay, so here we will go with the first concept, that is a specific heat capacity of some common substance. So in the books also you will be getting some values. Okay, so I have written on the right side of the board. Okay, so specific heat capacity of some common substance in the unit is joules per kg Kelvin. Okay, so let us understand the concepts very clearly now. So there are still more the substances and specific heat capacity. I have written only few. Okay, fine. So here you can see that, okay, the specific heat capacity of lead is 130 joules per kg Kelvin, mercury is 139 joules per kg Kelvin. So this specific heat capacity, why we need to study, why we need to understand this concept, what is the use of this thing? So in the previous class also I told that specific heat capacity will define the material. Consider the specific heat capacity of some material is 2 joules per kg Kelvin. That the value 2 joules per kg Kelvin will define some material. It may be iron, it may be brass, it may be any alloy, it may be wood, it may be cloth, anything. Okay, so that value will define different objects. Okay, so here also you are having different values. So what are all the materials that we have? In order to understand that one, I will just write, first one I will write what? Lead. So let us take all these concepts, all these materials in a beaker. Okay, so first one is what? Lead, and second one is what? Mercury, Hg, and third one is what? Brass. Okay, and fourth one is what? Iron, and fifth one ice, and the last one I will take water, not sea water, I will just take water. Okay, yes, so these are all the things that they have given there. How much it is there? How much quantity of lead is there inside this beaker? 1 kg. All the things are okay, so the quantity of the mass of all the materials are 1 kg. I kept in this beaker. Okay, fine. So why I took only 1 kg? Why? Because the unit is telling that it is joules per kg Kelvin. Okay, so per kg means what? Unit mass, that is 1 kg I am taking. All the masses are same, the materials are different, and specific heat capacities are different. What does this specific heat capacity indicates? To know that one, we are taking these examples. Now what I will do, I will give the same amount of heat to all the substances. I will give same amount of heat energy. Okay, fine. Q, I will give same amount. See, now if I give the heat energy, obviously the heat energy will be absorbed by those substances. Now consider the temperature of all the substances are 23 degrees Celsius. 23 degrees Celsius. All the substance temperature is 23 degrees Celsius. Now I wanted them to rise to 24 degrees Celsius. So to rise to how much? 24 degrees Celsius. Why? Because specific heat capacity definition says that specific heat capacity is the amount of heat required to rise the unit mass, the temperature of the unit mass to 1 degree Celsius. So let it be any mass, to rise its temperature to 1 degree Celsius, how much energy is needed? That is nothing but what? Specific heat capacity. Now all the substance temperature is 23 degrees Celsius, and now I wanted to rise to 24 degrees Celsius. To all the substances I am giving same amount of fire, that means same amount of heat energy. But all the substances will not, the temperature of all the substances will not rise to 24 degrees Celsius at the same time. Okay, so here if I give the heat energy to the lead, it may rise to 24 degrees Celsius, but when it is rising to 24 degrees Celsius, so it will take 130 joules. To raise its temperature from 23 degrees Celsius to 24 degrees Celsius, lead is taking how much energy? 130 joules of energy. In the same way, the mercury is taking how much? 139 joules of energy. Brass is taking 380 joules of energy. So and iron is taking 2000, okay, so not that is 554 joules of energy. Ice is taking 2100 joules of energy, and water is taking 4180 joules of energy. Okay, so these values will give us some conclusion that which is good conductor of heat. Okay, so to rise 23 degrees Celsius to 24 degrees Celsius, okay, so this lead is taking only 130 joules of energy. The materials which absorbs less energy, and if its temperature is raised very quickly, then we can say that it is a good conductor of heat. It is a good conductor of heat. So for example, if you take two person to do some work, okay, the person who will be having more stamina will do more work. Clear? Okay, so the person who will consumes less energy and gives more amount of work, we can say that person is powerful. So he must consume less amount of energy, but he must give more amount of work. So here it is consuming less amount of heat energy, but the temperature is rising very quickly. Here if we come to water, the amount of heat energy taken by this to rise to 23 degrees Celsius to 24 degrees Celsius is 4180. More amount is taking, okay, more amount of heat energy is taking. Hence, so this absorbs, since this absorbs more amount of heat energy, we can call water as what? Bad conductor of heat energy. Bad conductor of heat energy. So this specific heat capacity will tell, directly or indirectly tell, whether it is a good conductor of heat or a bad conductor of heat. So the material which absorbs more amount of energy to rise its temperature is usually the bad conductor of heat energy. Okay, the material which utilizes less amount of energy to rise its temperature is a good conductor of heat energy. Clear? Yes, fine. So upon this concept, they will frame some application level question. So no need to memorize these things, but you need to know. So when we have to call a substance as a good conductor of heat, when we need to call a substance as a bad conductor of heat. Clear? Yes. This is the concept. This is what we need to understand under the concept specific heat capacity of some common substance. Now let us move to the next concept, which is the concept that is principle of method of mixtures, or principle of calorimetry, with the help of a device called calorimeter. Yes, the next concept is what? Principle of method of mixtures, or principle of calorimetry. Okay, so in order to understand this one, there is a derivation here. Okay, so there is a derivation. So in order to get that derivation, we need to know about a device called as calorimeter. Okay, so here we need to do some experiment. While doing this experiment, we cannot do it okay, so in an open environment. So we need some device, and the device is called as what? Calorimeter. Clear? Yes. What do you mean by calorimeter? Calorimeter is a device which measures the amount of heat lost or heat gained. So it will measure the amount of heat lost or heat gained when two substances are mixed together. So consider the two substances when they are mixed together. So obviously two substances will be having different temperature. We need to take those type of substance in which the temperature of those two substances are different. One should be hotter and one should be colder. When they mix together, so what is the amount of heat transfer happened? So that in order to measure that one, we have one device called as calorimeter. This is the definition of what? Calorimeter. So the setup of calorimeter is like this. There is a stand here, and stand has been connected with one thermometer, and thermometer is directly dipped into the vessel. This vessel is made up of copper. Okay, so the copper, and then since there should not be a loss of heat. Okay, so by keeping this in mind, so the device includes a jacket called as wooden jacket, and there is a gap between this copper vessel and wooden jacket, and that one will be covered by hool. Why? Because hool is what? It is a bad conductor of heat absorber. Okay, so it is a bad heat absorber, hence so the hool has been kept here. So the complete objective of this device is whatever the substance we will pour inside this vessel, copper vessel, the temperature and the heat energy should be within that vessel only. It should not go out of the water, this device. So to make that one happen, so there are some substances from which we will take the help. Okay, so upon this there is a rubber cork, and everything has been insulated. There is no chance of what? Escape of heat energy from when the substance enter inside to the outer atmosphere. Why? Because usually we know that heat transfer takes place in three methods. Okay, so one is conduction. Okay, second one is convection, and third one is what? Radiation. So radiation. To avoid the heat loss from these three heat transfers, okay, so this device is much more needed. Clear? Yes, fine. So now, what do you mean by conduction? When two objects are kept in contact together, there will be the heat transfer. So by conduction, the heat transfer has to happen inside. Okay, so when we heat a body, for example, take a beaker of water. Okay, take a beaker of water. When we heat that water, okay, so the lower part, okay, so of this vessel are they will be connected to the water material. Okay, so initially those material will be heated first, and they will move up, and the upper part in which the cold molecules and atoms are there will come down. So this transfer of heat from the hot body to the cold body, so that means the heat is transferring from hot molecules to cold molecules. This type of heat transfer is called as what? Convection. And then there is a radiation. So because of this heat transfer, the water vapors, okay, through water vapors or through radiation, okay, so through the process of radiation, the heat will be lost to the atmosphere. And if we keep our hand upon the boiling water, we can feel that the heat. Clear? So that type of heat transfer is nothing but what? Radiation. The best example for radiation is the sun rays coming from the sun. Sun and earth are not in contact together, but then also, so the earth surface will be heated up with the help of the rays that is coming out of the sun, but they are not in contact together. How it is coming? Because of the radiation, electromagnetic waves. So all these things. So the process in which the heat transfer occurs, okay, so from one body to another body, when they are not in contact together, through radiation, through waves, through electromagnetic waves, are called as what? Radiation. These three are the process of heat transfer. Clear? Yes, fine. So to avoid these things, that means convection, okay, so the radiation, so this complete setup has been the complete setup has been utilized. Okay, this is the usage of what? Calorimeter. Now what we need to do is, what does this principle of method of mixture says is, we need to insert two substances, two liquid materials, say, okay, so material A and material B, material A and material B. So material A will be having the higher temperature. Let me take the temperature as T1. It will be having the more temperature. The body is the, okay, so hotter body, and material B will be having the lower temperature, the less temperature compared to T1. Okay, material A will be having, since the material is only different, the specific heat capacity will be different. That is, let me take that as C1, and material B, let me take that as C2. Okay, next. This one, okay, the mass of the material, let me take it as M1, the mass of the material, let me take it as M2. Okay, fine. So what we have to do by taking these two materials? We have to pour these two materials inside this the calorimeter. When we insert those two materials, there will be the heat exchange, there will be the heat transfer that takes place from material A to material B. Okay, so why? Because material A temperature is more than material B. Okay, fine. So according to the conservation of energy, okay, what does this conservation of energy tells? This tells that energy can neither be created nor be destroyed. It can be transferred from one form to another form. So by utilizing that conservation of energy, okay, it is not conservation, it is conservation of energy, we can have the equation that, okay, so the definition that heat lost by hot body, which is the hot body, material A is the hot body, will be equal to heat gained by cold body. Okay, so according to the conservation of energy, okay, law of conservation of energy, heat lost by the hot body will be equal to heat gained by the cold body. Okay, so material A is the hot body and material B is the cold body. The energy lost by material A will be equal to the heat energy gained by the material B. Okay, fine. What is the amount of heat lost by the body? Okay, so heat energy lost by material A will be equal to, so the equation says that heat energy equal to mass into specific heat capacity into delta T. What is the mass of material A? M1. Specific heat capacity is C1. Okay, what is the change in temperature? Change in temperature is nothing but, okay, so I'll write here, change in temperature is nothing but maximum value minus minimum value. Okay, so maximum temperature minus minimum temperature. Change in anything is nothing but what? Maximum value minus minimum value. Correct? What is the maximum temperature that it is having? The maximum temperature is what? T1. What is the minimum temperature that it will attain? So after some time, so both the temperature, the T1 and T2, so the temperature T1 will decrease, temperature T2 will increase. So they will attain some stage. Clear? So they will attain some stage, and that temperature, okay, so the equilibrium temperature, okay, so the equilibrium temperature or okay, so after some time the temperature that they attain, let us take it as what? T. Okay, so now maximum temperature is what? T1, it will not attain T2 temperature. Why? Because when the heat transfer takes place, the temperature T2 also rises according to conservation of energy. Correct? So hence the maximum temperature is T2 and minimum temperature is T. So the change in temperature will become T1 minus T. So maximum temperature is T1. Okay, why? Because the maximum temperature here is what? T1, and the minimum temperature that it will attain is at equilibrium stage, it will be T. So hence change in temperature will become what? T1 minus T. Clear? Yes. So now heat gained by material B will be equal to mc delta T. General formula, what is the mass of material B? That is m2. Okay, and the specific heat capacity is what? C2. And change in temperature, what is the maximum temperature that it will attain? It will attain a temperature of T. So it will lose some amount of energy, and it will also attain the temperature T. So after some time it will gain the energy and it will attain the temperature T. So therefore the maximum temperature will be T. What was its minimum temperature? That is T2. Clear? Yes, fine. So now by this equation, if we substitute here, okay, heat lost by the hot body is nothing but what? M1 C1 T1 minus T, okay, which will be equal to, here if I substitute, M2 C2 T minus T2. Okay, so this is the equation for principle of method of mixtures. Okay, this is very simple and we need to memorize this formula. Here, what do you mean by T1? It is the temperature, the maximum temperature of the object hotter body. T2 is the minimum temperature of the cold body, or the temperature of the cold body, and T is the what? Equilibrium temperature. After some time the heat transfer takes place, and at certain stage the temperature of both the objects will remain same. That temperature is nothing but what? T. So this is the equation for principle of method of mixtures. Clear? Yes, fine. So we will utilize this formula to solve the problems. In the next video we will solve the problems. Now let us move to the next concept, that is some natural consequences due to specific heat capacity of water. Clear? Yes. Let me rub this. So the next concept is what? Natural consequences and phenomena of high specific heat capacity of water. So water is a unique thing. Okay, so we have n number of applications with respect to water, and high specific heat capacity, the property of water to have high specific heat capacity will also give one more important application, and because of that application, these are the advantages that we will face. Okay, so there are 5 to 6 advantages. So it is very interesting. Okay, so just what we need to understand the concepts very carefully. Okay, so let us come from the last one. The last consequence that we have is plants and animals have a high content of water in the body. Okay, so why we need high content of water? Okay, inside our body blood is there, and okay, so all the other the chemicals and all the other things are there. Okay, so but most of the volume is covered by water. Nearly 70 to 80% of our body will be covered by water. What is the utilization of this one? Okay, so in the atmosphere there will be abrupt changes in the temperature in the atmosphere. Sometimes the temperature will go low and the temperature will be higher. So when the temperature is low in the surroundings, there also the heat transfer takes place. Why? Because our body is in contact with the atmosphere. There the temperature will not come from the cold air into our body. So because our body will be having this water which is having high specific heat capacity, that means it will be having more energy stored, heat energy stored. Now the temperature has to move from our body to the air, atmospheric air. So when this happens, when the temperature goes down, then also since our body is having this water which is having high specific capacity, which holds the temperature for a longer time, which absorbs the heat energy for a longer time, and when the temperature is decreasing also, it will not decreases its temperature rapidly. The body's temperature will not decreases rapidly, so it will take time and it will decrease the temperature slowly, by which the time elapses, and once again the temperature within that time the atmospheric temperature increases. So this will helps us to maintain the body temperature in spite of lowering the atmospheric temperature. This is the utilize of the high specific heat capacity of water. I hope you understood this concept. Next one, farmer fill their field with water to protect the crops. Okay, so there is a condition called as frost. Okay, so from frost, what do you mean by this one? Okay, so the concept is very interesting. So try to understand. Okay, so this is the farmland, and there is one tree here. There is one tree. Okay, so consider the atmospheric temperature is going low. Okay, so as for example 5 degrees Celsius. Okay, so now it is decreasing up to 3 degrees Celsius, or it may go up to 0 degrees Celsius. When the atmospheric temperature decreases, so the temperature, okay, so the water content and the earth's temperature, the ground temperature also decreases. Okay, so why? Because here the earth's temperature, the specific heat capacity of the materials which is present on the earth, for example sand or mud, so it is very less. When the temperature, atmospheric temperature decreases, here also the ground's temperature also decreases, which results here what will be there? The roots will be there. The roots are connected to the veins which transfer the water, but the water here, whatever the water is there, the temperature is very less. When these veins, roots and veins are for example we will call it as xylem and phloem, so when they absorb this water, but the temperature is very low, since the temperature is very low, there is a chance that the water will get converted into ice. When the water get converted into ice, okay, so when liquid get converts into solid, the volume increases. Okay, the volume increases. Now the veins are in the shape of pipes. Okay, so now the water has to enter. Because of this change in temperature, decrease in temperature, the water is getting converted, which is moving in the veins will get converted into ice, in which the volume increases. Because of that, the veins may burst. That condition is nothing but what? Frosting. So to avoid that one, what they will do, they will just store the water up to certain level, so that this water, since it has high specific heat capacity, when the temperature decreases, the temperature from the water will be transferred to the atmospheric air. When this happens, so the temperature will not enter, the lower temperature will not enter to the ground. So this water will safeguard this groundwater from which the roots will absorb the water. So here the temperature will not decrease from here to here. Okay, so the ground temperature will remain same, since upon that water is there, which will not allow the temperature to decrease. Okay, so why this happens? Why? Because of high specific heat capacity. So by that the veins will be safe. Clear? Yes, fine. So this is one of the another one advantage or application. Next, water is used as the reservoirs in cold countries. Okay, so in cold countries, usually to keep safe the wines and other the liquid materials, they will use what? Water as the reservoir, since it has a high specific heat capacity. Next one is what? The water is used as an effective coolant. Okay, so this is very important. See, consider an engine is working, car engine is working. So because of this what? The friction, okay, the movement of two or more metallic body, there will be a friction. Because of friction, what will be created? Heat energy will be created. So when the body, when the engine bodies, so the cylinders and pistons are moving, okay, so when the engine is when the vehicle is moving, the engine has to run. When the engine is running, the temperature keeps on rising. So now by this, to maintain this engine, okay, in a good way, we need to put some water, some substance in terms of what? Coolant. That means the temperature which is there in this engine has to be transferred to atmosphere. And so there what will be used? The water will be used. Why? Because water will be having a high specific heat capacity. This high specific heat capacity water, what it will do? It will absorb the heat energy generated by this engine, and it will absorb more amount of heat energy. Why? Because to rise it, if the temperature is rising, for example 350 350 Kelvin to 360 Kelvin, if the temperature is rising, okay, so to rise here 10 degree Kelvin, it is utilizing some amount of heat energy. But here water, if it is rising to 350 degrees Kelvin to 360 degree Kelvin, so the amount of heat energy required to rise 10 Kelvin will be much more greater than this material. Okay, so that means it will absorb more amount of heat energy from this engine, so that it will keep the engine safe. Hence, water is utilized as an effective coolant. Okay, yes, fine. Now, the next one is what? The hot water bottles are used for fermentation. So this fermentation is a process in which usually it is a medication process in which we will use some hot water bottles to keep it on the skin or wounded areas, okay, so that it will ease the pain. Okay, so there also we will be using what? This water. Why? Because since it is having high specific heat capacity. And the first one is very important. Okay, so very important. Here the climate near the seashore is moderate. Okay, near the seashore the climate will be average. Why? Because, so consider this as land, and okay, so from here water is there, this is the sea. Okay, fine. So the sun rays from the sun will fall on the sea and water in a, okay, so in a equal manner. For both the thing, the heat energy due to radiation, the heat energy is, okay, so they are acquiring is same, but the temperature here will rise slowly, and temperature here will rise fast. Why? Because the land's specific heat capacity will be less, and water specific heat capacity will be more. So as it absorbs the heat energy more to raise the temperature, as it absorbs less amount of heat energy to raise the temperature, this will create the difference in temperature. When this difference in temperature happens, here the amount of heat energy that is liberated also will happen slowly. Why? Because it is having high specific heat capacity, so it will liberate the energy, okay, very slowly, and that will heat the what? Atmospheric air. When this atmospheric air will get heated up, okay, so it will move to the what? Land place, and the atmospheric air which is present here, when this the temperature will rise abruptly and it will fall abruptly. When it falls abruptly, here also the atmospheric temperature, which is atmospheric air present here also, so the temperature of that one also will falls down, and here the air which is present on the land will move to the sea. So the air currents happens due to the changes in the temperature because of a high specific heat capacity of water. So this will maintain the temperature in the seashore, and it will be usually moderate. Clear? Okay, fine. So these are all the concepts which comes under the natural consequences and phenomena, theoretical concept, which we need to observe carefully and understand the concept. So I hope you understood all the things very clearly. So if any doubts or any queries are there, then please put a message in the comment box, put a comment in the comment box, and we will solve the problematic questions in the coming video. Okay, so in the coming video I will be solving each example questions and exercise questions as per the textbook which I am referring, that is Selina Publishers, and as per the syllabus, that is ICSE. I hope you understood all the concepts. Subscribe, share, and support us. Thank you.